know that when we are at the local minimum or the local maximum of a function, the derivative is equal to 0. And we can use this to solve problems. Example. We have a piece of y which is 12 centimeters long, and we bent it to make a rectangle. What are the optimum dimensions for the rectangle to have the largest area, the largest possible area? So okay, okay, so basically the rectangle could be like this, and the total perimeter here would be 12, or it could be like this, and the total perimeter would still be 12, but obviously the area here would be different from the area 1, and we want to find the dimension, which I'm going to call x and y, such as the area is maximum. Okay, so what can we say? We can say that the perimeter is equal to 2x plus 2y, which we can factorize at 2x plus y, whereas the area is xy. We know that the perimeter is equal to 12, so therefore we have a relationship between y and x, which is x plus y equals 6, so therefore y equals 6 minus x. And so from there we can rewrite x times 6 minus x, which is minus x squared plus 6x. When is this value maximum? Oh, so it's a parabola, okay? So it's a parabola because the coefficient of x squared is negative. It's a parabola which is going to be concave down, and so there is going to be a maximum. Right, so the maximum, this area is a function of x. So we need to find the derivative. The derivative is what? Minus 2x plus 6. So the derivative f prime of x is equal to 0 when x is equal to, well, not too difficult, when x is equal to 3. So at that point, the area is maximum and equal to 3 times 3, which is 9. Because basically y is also, y being 6 minus x is equal to 6 minus 3, which is 3. So in fact it's a square. And indeed the perimeter is 12. Right, let's do another one. We have a sheet of cardboard which is 15 by 7 centimeters. And we are going to cut 4 squares out of the sides to make it a rectangular box. There you go. So we cut this 4 square to make it a rectangle. That's the imprint, and then we will fold it here to make it a rectangular box. So at the moment it's 15, this distance, and 7, this distance. And so we will cut it a bit, which is say x, And okay, we want to find the value of x for which, as you would have guessed, the volume is max. Okay, so what can we say? We can say that 2x plus we can say that 2x plus this distance that I'm going to call a, 2x plus a equals 7, and we can say this is going to call b. So we can say that 2x plus b must be equal to 15. And what is the volume? The volume must be a b x. Okay. So therefore, okay, so from equation 1, we get a is equal to 7 minus 2x. And from equation 2, we get b is equal to 15 minus 2x, which we can substitute in the formula for the volume, which depends of x. And it's 7 minus 2x times 15 minus 2x times x. Okay, well, let's expand that. That's 4x cubed. Then we have the term in x squared, which are what? 4, and then minus 30, and then minus 14. Then we have the term in x, which are 7 times 15, 7 times 15 being 105. So okay, well, let's simplify that a little bit. That's what? 4x cubed times 4 minus 30 minus 14 minus 40x squared. And then plus 105x. Okay, so when is this volume at the maximum? Well, we need to find the derivative. So the derivative is 12x squared minus 80x plus 105. Delta is, we need to find the root for this. Delta is equal to b squared minus 4ac, which is 80 squared minus 4 times 105 times 12, 1360. Yes. And so therefore there are two roots, which are x1 is minus b 80 minus root of 1360 over 2a, 2 times 12. This is approximately equal to 80 minus root of 1360 equal, divided by 24. I found 1.79 approx. Whereas x2, well, x2 there is no need to calculate it because it's going to be, actually no, that's going to be 80 plus root of 1360 over 2a, and that's going to be 80 plus root of 1360 divided by 24, 4.86. However, this one, that doesn't work because that would result in a being negative, and a being negative, that's impossible. So that's the only one possible. And what is the volume? Well, an approximation of volume would be So A times B times X, using basically the value of X that I found here. And by finding the value of A, B, now that I know the value of X, I would be able to find the value of the optimal volume.